Yes, same the guy. Today let's talk about monobactams. Monobactams are also class of beta-lactam antibiotics as penicillins, cephalosporins, and carbapenems. So we want to see how do they differ from those other beta-lactam antibiotics and how do they differ from other antibiotics. Now let's see. So why are they called monobactams? We saw that in penicillins, cephalosporins, and carbapenems, the beta-lactam ring is attached to another ring, but here it's not the case, so it's only beta-lactam ring, so that's why they are called monobactams. About the structure-activity relationship, this group is very essential, so it activates the ring. Then this other group, it increases stability to beta-lactams. So it's for beta-lactam stability. Beta-lactamase stability. It increases the stability against beta-lactamases. Then for this group, it's also the same case. It also improves stability against beta-lactamases. Then this R1 group is responsible for spectrum of activity. So these groups in red, they are very essential, so they shouldn't be tampered with. They should be there for activity. By those in blue, they can be modified. Then for natural monobactam, or the first monobactam is sulfasalazine. Sulfasalazine has this structure. It has this structure. Then here there is a methyl group. Then we have a 1, 2, 3, 4. Then that's its structure. Here there is a methoxy group. That's the first monobactam isolated from the soil bacteria, the saprophytic soil bacteria, or soil saprophytic bacteria. Anyway, then some of the properties, of course, it has this group which increases the activity. Then it has this methoxy group. This methoxy group, it increased the beta-lactamase activity. Stability, beta-lactamase stability. But this group decreases the potency against gram negatives. Then we have this side chain. Of course, it is more of the hydrophilic. So these monobactams, the spectrum of activity, they act more on gram, or they are narrow spectrum, they act on gram negative bacteria. They are narrow spectrum. So now These are the drawbacks: it has low potency and drawbacks. It has low activity. It has low bacteria activity. It was found that this Monobactam has low bacteria activity, but it had a high beta-lactamase resistance. It wasn't degraded by it was degraded less by beta-lactamases, but for bacteria activity it was very low. Of course, low bacteria activity generally, of course, for gram positives and gram negatives. So they had to modify this sulfazine to make other monobactams. One of them is azetrionum. In azetrionum, this is its structure. They removed this group. Removing this group is they put a methyl group here. This methyl group also had beta-lactamase stability. It increased the stability against beta-lactamases. So meaning that for the problem of beta-lactamases, at least it's not there, it is stable. Then here, this R1 group, they substituted a structure resembling that of the cephalosporin. That cephalosporin, remember cephalosporin is one of the third generation cephalosporins. So substituting that group here increased the activity against the gram negatives. It increased the activity. So it can target even those resistant bacteria as those inhibited by the third generation cephalosporins, including the Pseudomonas aeruginosa. So remember, third generation cephalosporins, they have this structure. They have the amino ring, and here they have the methoxy group or the alkoxy group at this amine here. This group, so we have a carbon CH3, a CH3, and carboxylic acid. So this is the isobutyric acid. So substituting this group, so if you look at this part, the whole of this part is like that of the cephalosporin. This is the third generation cephalosporin. So this one, we improved the activity. The gram negative activity was improved. Including those Pseudomonas species. Including those Pseudomonas species. And presence of that methyl group, the methyl group increased the beta-lactamase resistance. So beta-lactamase resistance. Of course. So that's what was done on azetrionum. Then there are other there are other monobactams. For example, Tigemonum. If you look at Tigemonum, instead of this azetrionum, instead of this group here, they substituted they substituted a structure resembling that of the cephalosporins. Remember, third generation, they have all these parts similar, but they just change from here. Also, they have the alkoxy group, but for Tigemonum, it is CH2COH. So that structure resembles cephalosporin. So now this structure is for, now it's not azetrionum, it is Tigemonum. And also, instead of a methyl group, they added another methyl group for Tigemonum. So addition of a methyl group here, this one, of course, it increases the beta-lactam resistance, but it decreases the activity against gram negative, decreases the potency or the activity against gram negative. But of course, we have this group. So this group, it will compensate for this group. So this is for Tigemonum. Then we saw the azetrionum. Now, formulation is like that of the carbapenems. For formulations, it is sterile, lyophilized powder, they are also not stable when they are in solution form because of the presence of the nucleophiles, and they are not stable in acid and in acidic condition or alkaline. So they are parental. They are not given orally. If they are given orally, it's for treatment of the localized GIT infections because they have poor solubility if given orally, but they are given parentally. They are formatted as lyophilized powder. Also, if this solution, in solution, when it is reconstituted solution or reconstituted solution, if it is reconstituted, it can last for 48 hours. Those are 2 days. But if not, like in fridge, yeah, or in a refrigerator. But if they are freezed, they can last for a week, like 1 week in a refrigerator if they are reconstituted. Thank you guys for watching. It's MK the guy. Please don't forget to share, subscribe. Also comment.